NVIDIA's latest AI systems are becoming more powerful every year. Data centers are getting larger. AI factories are getting more dense. And there's one problem that comes with all of it, and that's heat, and lots of heat. And every time a GPU performs a calculation, it consumes electricity. And eventually, nearly all of that electricity becomes heat. The more powerful AI becomes, the more heat it creates. And that's creating a challenge that many investors are not paying attention to. Because if AI can't stay cool, it can't keep growing. And some of the newest AI racks are becoming so power dense that traditional cooling methods may no longer be enough. And that is creating what could become one of the next major bottlenecks in AI infrastructure. So in today's video, we're going to look at why cooling is becoming increasingly important and 3 stocks that could benefit from this trend. So to understand the opportunity, we first need to understand the problem. AI models are continuing to grow larger. Training runs require more compute, and inference workloads continue to increase, and hyperscalers are deploying more GPUs than ever before. So the result is data centers are consuming enormous amounts of electricity. As only a few years ago, the traditional server rack might consume only a fraction of what today's AI racks require. And now we're seeing power requirements climb dramatically. And every watt consumed eventually becomes heat. And the AI industry isn't just building bigger data centers, it's building hotter data centers. If you can't remove the heat, performance suffers. And that's where cooling enters the story. So for decades, data centers relied on air cooling. Fans moved air conditioners removed the heat, and that was usually enough.
A lot of heat is generated inside data centers by servers that power the apps and services we use every day. All that heat needs to be removed to keep the equipment running. And that requires cooling systems that use some combination of energy and water. So, how are those two important resources actually used? Data centers use separate systems for cooling the servers, where the heat comes from, and cooling at the building level, where the heat is removed from the facility. For cooling at the server level, there are 2 main options. Air cooling uses fans and air conditioning to move hot air out and cool air in. The other option is liquid cooling, which is a closed-loop system that sends cooling liquid directly over the processing chips inside servers, where it absorbs the heat and then carries it away.
But now AI is changing the equation from just air conditioners. Modern AI systems are becoming so dense that air cooling is approaching its practical limits. And that's why many companies are shifting towards liquid cooling solutions. Liquid transfers heat more efficiently than air. It allows operators to run denser systems. It can improve energy efficiency, and it helps support the next generation of AI infrastructure. Cooling is no longer a secondary consideration. It's becoming mission critical. One reason why cooling has suddenly become such a big opportunity in NVIDIA's latest generation of AI hardware, as systems become more powerful, rack densities continue to rise. AI factories are packing more compute into smaller spaces, and more compute means more heat, a lot more heat. And the AI industry isn't simply building more data centers, it's building more powerful data centers. And that's one reason cooling demand is accelerating along AI demand. It's one reason many companies are investing heavily in liquid cooling infrastructure. Here is how Microsoft deals with cooling their data servers.
To keep them running safely and efficiently, data centers use cooling systems. These systems rely on different methods, like air, water, and special liquids, to remove heat, while also saving energy and reducing water use. At Microsoft, we work to cool our data centers using as little water as possible. In many places, we use outside air to keep our computers cool most of the year. In Sweden, we can do this all year long. In places with warm days, over 85 degrees Fahrenheit, we use a system called direct evaporative cooling, DEC. It pulls in outside air and some water to make the air cooler. This cooling type uses less energy than air chillers, which are similar to air conditioners. The water for direct evaporative cooling comes from the local water utility and is circulated between 2 and 5 times in our system before it goes back to the utility to be cleaned, just like water that goes into a drain from a sink or shower. Before we build our data centers, we work with local water companies to make sure we're not using too much on those warm days. And if new pipes or systems are needed, Microsoft helps pay for them so the community doesn't have to. In temperate places like Ireland, we only need to use water for about 19 days a year. In hotter places like Georgia, we use water for about 55 days a year. We are also evolving our data centers to use new technology called liquid-to-chip cooling. It brings a special liquid right to the computer chip to cool it down. This liquid stays in a closed loop, so we don't need to add more water after the first fill, making it more energy and water efficient. At Microsoft, we care about saving water and building data centers that are good for communities and the planet.
Over the past year, investors have focused on several AI bottlenecks with power, memory, compute, networking, and bandwidth, but cooling may be joining that list. And without power, AI doesn't run. Without networking, AI can't communicate. And without memory, AI slows down. And without cooling, the entire system struggles to operate efficiently. Cooling may not get the same headlines as GPUs, but it is becoming one of the most important pieces of the AI infrastructure stack. So when investors hear cooling, they think of air conditioning, but cooling is actually an ecosystem. There are companies focused on facility cooling, others focused on rack cooling, and others focused on direct to chip cooling technologies. Some companies are investing heavily in liquid cooling.
A super efficient way to regulate hardware temperature is with liquid cooling. This method uses pipes to circulate liquid, typically either water or specialized coolant, to quickly and efficiently absorb heat directly from the equipment. Liquid cooling is effective because liquid conducts more than 3,000 times as much heat as air and requires less energy to do so. That efficiency allows data center operators to stack more servers into fewer racks for higher density arrangements that can meet growing processing demand while saving energy. The most common liquid cooling method for high-power, data-intensive tasks like AI is direct-to-chip cooling. Here's how it works. Chilled cooling liquid starts inside a heat exchanger, which sends it directly to the servers. This cooling fluid flows over metal plates attached right to the processing chips, pulling away the intense heat they generate. Once the heat is absorbed, the liquid flows back to the heat exchanger, where it's cooled and recirculated. But it doesn't stop there. The heat exchanger then transfers this heat to a secondary cooling loop, which rejects it from the building entirely. By combining liquid cooling with an external cooling system, data centers can efficiently manage high-power AI workloads and support next-generation digital services, all while using energy and water resources more sustainably.
So regardless of each company's approach, the goal remains the same: remove heat as efficiently as possible. And that brings us an important point. Every AI factory needs four things: compute, power, networking, and cooling. And remove any one of these four pieces, and the factory does not work. So, if you want proof that cooling is becoming a major AI theme, look no further than Vertiv. VRTV. Vertiv is one of the leaders in AI infrastructure. Stock ticker VRT.
With high-performance computing on the rise, high-density IT environments are creating cooling challenges that are increasingly difficult to manage. Air cooling may no longer be effective or efficient. Enterprises need alternative cooling technologies, and fast. Liquid cooling is emerging as the answer, but data center managers have very specific requirements about introducing liquids into the rack. The new Vertiv Liebert XDU 450 and 1350 usher in the next generation of liquid cooling technology, designed to seamlessly fit into your IT environment, engineered to reliably and efficiently manage your high-density thermal loads. First, the Liebert XDU supports rear door heat exchange or direct contact liquid cooling, giving you the flexibility to meet the needs of your unique application and the efficiency to manage power-dense hotspots up to 450 kilowatts or 1,368 kilowatts of heat. The distribution unit.
The company provides cooling systems, power systems, and other technologies used inside modern data centers. Recently, Vertiv raised its 2026 guidance and now expects between $13.5 to $14 billion in revenue. And more impressively, the company reported approximately $15 billion in backlog orders. That backlog matters. You don't accumulate $15 billion in future business unless customers are spending aggressively. And that's exactly what we're seeing from hyperscalers building AI infrastructure. Vertiv is also expanding liquid cooling production and strengthening its position within the NVIDIA ecosystem. And in many ways, Vertiv validates the entire cooling investment thesis. The challenge valuation. The stock has already delivered enormous gains and expectations remain extremely high. But if cooling demand continues growing, Vertiv appears well positioned to benefit. And once cooling becomes a priority, the next question is who benefits beyond Vertiv? Enter nVent, NVT.
It plays a key role keeping things cool in the red-hot world of AI and data centers. Frank Vassalero introduces us to nVent and the woman who runs it.
Every day, millions of us use AI applications like ChatGPT. That requires power from data centers like this, where chips and servers run the digital world. The process generates massive amounts of heat. If it gets too hot, circuits melt. So data centers must be cooled. nVent is growing to be the king of cool.
From the other end of the building where we started was about 5,000 square feet to where we are now is about 130,000 square feet in the last about 7 years that we've grown this business.
That's like 10 times growth. That growth means 3 shifts a day plus weekends at this Anoka plant. They make products like these manifolds that carry water to cool data centers. They are laser measured to meet exacting standards. Spearheading this effort from headquarters in St. Louis Park is CEO Beth Wozniak.
So nVent is an electrical manufacturing company, and we spun out of Pentair around 7 years ago. And we had to invent our name. And when you look at what we've done, over 100 years of innovation. So we're in data centers, we're in utilities, we're really part of the electrification of everything.
nVent is a public company whose stock has risen about 50% in the last year. They employ about 12,000 people worldwide, including the Canadian-born CEO who came to Minnesota decades ago to work at Honeywell.
I have a background in engineering physics, and I started my career doing aircraft simulators, but then got into all kinds of different products within aerospace and also in automation and controls. And that led me to where I am today.
Today, she is leading a company in a field where most CEOs are men. But Wozniak sees more opportunities.
And one of the things I'm very proud of nVent is that we have a lot of women executives. And when I look at the board for nVent, over half of our board are women.
Business is hot right now, in part because AI demand is booming. nVent faces challenges most companies would welcome.
It's taken us 100 years to build out the electrical grid capacity that we have today. That needs to double in the next 25 years. And then you see the rate of growth of data centers. So one of our challenges is, quite frankly, expanding our capacity to serve all the needs that we have from our customers.
Enough customers to increase revenue from $2 billion when the company started to nearly $4 billion this year.
Management also raised guidance significantly to $4.55. And to me, this is one of the more interesting under the radar names in the cooling theme. And while Vertiv gets most of the attention, nVent may still be early in its AI re-rating story. Modine, MOD, may be the most interesting company of the three. Most investors still think Modine as an industrial HVAC company, but the company is rapidly transforming into a climate solutions business with increasing exposure to AI infrastructure.
I'm the general manager for our immersion portfolio here at Airedale. I've been in the IT industry for over 30 years, doing large-scale IT transformation initiatives with major Fortune 500 companies basically across the globe. So we're at a really, really exciting point in the marketplace right now. We've got all of the growth which took place historically in the cloud business, and now the cloud business is basically transitioning over into AI and machine learning and seeing a huge growth cycle on that. Our system is specifically designed to support high density, high performance compute, which is where we're seeing the significant growth within the marketplace. The systems we're developing today can support the new generations of GPU and CPU architectures that are coming out from major silicon manufacturers. And our systems and our platforms are designed to scale significantly higher in terms of what the capabilities that we perceive will emerge in the marketplace over the next 2 to 5 years. In terms of the challenges that are taking place today in the data center marketplace, we've got a legacy of air-cooled data center infrastructure that's been in the marketplace for the past 40 to 50 years. We're now getting to the point where when it comes to high performance compute, we now need to shift to a mix of either hybrid liquid strategies or pure liquid strategies. What's very, very different about this particular platform is we can take enterprise class servers, which normally can only run in a data center, put them into our EdgeBox platform, and essentially deploy them anywhere. In our past life, where we would take the data and move the data to the data center, we now have the ability to essentially take this data center in a box and move it to the point of data creation. So that's a huge change. Another facet about this is highly energy efficient as well. Because we remove all the fans and everything, we can get up to about 35% energy reduction in terms of the actual performance and operation of these platforms. This is a really pivotal point in the marketplace. We're seeing huge inflection points in terms of what's actually happening from a data center architecture, what's actually happening in terms of the enabling chip technologies from the various silicon manufacturers, and most importantly, the actual speed that everything is actually taking place at. We are pumped and excited to go out there and basically attack this marketplace and basically be able to address all the needs in response to what we're seeing from a dynamics perspective in the customer base.
Recently, Modine announced a massive $4 billion long-term data center cooling agreement from 2027 to 2029. That deal alone dramatically improved long-term revenue visibility. But one detail stood out to me. The customer provided Modine with a $165 million upfront payment to help expand production capacity. So think about that. Customers aren't simply ordering cooling equipment. They're helping finance future production. And that's a strong signal that demand remains robust. Management expects data center revenue growth roughly 60 to 80%. And the company is also simplifying its business and focusing more on climate solutions. And of course, there are risks. The stock has already had a strong run as price for earnings ratio was about 113. Valuation has expanded, and supply chain constraints could create challenges. But if AI cooling demand continues growing, Modine could become one of the more interesting transformation stories in the entire cooling ecosystem. So why this could last for years, as every AI factory requires compute, power, networking, and cooling. As AI infrastructure spending increases, cooling demand grows alongside it. This isn't a one-quarter trend, and it could be a multi-year infrastructure build-out. And while GPUs tend to capture most of the headlines, the supporting infrastructure may create opportunities of its own. 5 years ago, investors focused on software, and they focused on chips. Today, some of the biggest opportunities may be found in the infrastructure supporting those chips. Vertiv proves cooling is becoming essential. nVent shows the theme is expanding. And Modine may offer one of the most interesting growth stories in the entire cooling ecosystem. If AI continues to scale, cooling could become one of the most important parts of the AI infrastructure stack. So please hit the like and subscribe button if you enjoyed the video. And if you'd like access to my portfolio, stock research, visual from today's video, and watch list, check out the Buy Me a Coffee link below. And check out the membership page. And thanks for watching. We'll see you in the next one.